Some objects in the universe have magnetic fields so powerful they can warp atoms and affect Earth from thousands of light years away. This audiobook explores magnetars, extreme neutron stars that concentrate unimaginable energies in a body the size of a city. A journey to the edge of matter, where space-time trembles at a mere burst. Magnetars are a special type of neutron star, but they are not just that. They are characterized by having an incredibly strong magnetic field, millions of times more powerful than any magnet we have seen on Earth. This extreme magnetic field not only distinguishes them from other neutron stars, but also grants them unique properties and behaviors that help us better understand the cosmos. But why are they so important in the study of the universe? The relevance of magnetars lies in the fact that they are natural laboratories of extreme physics. They offer us a window into the conditions that prevail in the darkest and most mysterious corners of space. By studying them, scientists can explore fundamental concepts of astrophysics and theoretical physics, from relativity to quantum physics. Magnetars show us how matter behaves under conditions that we cannot replicate on Earth. Now, how does a magnetar form? From the explosion of a massive star, the core collapses and becomes a neutron star. If conditions are right, that neutron star can develop a colossal magnetic field, becoming a magnetar. This process is fascinating, as it allows us to see how the death of a star can give life to such an extreme object. But what happens after a magnetar forms? Magnetars are not static. They are dynamic and often very active. Their magnetic field is not only strong, but it also changes over time, which can trigger spectacular phenomena like gamma-ray bursts. These explosions are so intense that they can be detected billions of light years away, giving us clues about the nature of these peculiar objects. The magnetic field of a magnetar is a true colossus of the universe. To put it in perspective, if we could get close to one, the force of its magnetic field could crush any object that got too close. Imagine a fridge magnet, but on a cosmic scale. This field can affect not only its own structure, but also the matter around it, creating a hostile environment for any form of life. The activity of magnetars does not stop there. They emit X-ray pulses that are like bright signals in the vast ocean of space. These pulses are the result of the magnetar's rapid rotation and intense magnetic activity. Each pulse tells us a story about the internal structure of these objects, like a code that we are just beginning to decipher. While magnetars are fascinating, they are also terrifying. Their energy can influence the formation of new stars and galaxies, making their existence have a much greater impact than we imagine. Each magnetar can be a catalyst for the creation of new stars, a reminder that death and life in the universe are inextricably intertwined. As we investigate more about magnetars, we realize that they are also related to gravitational waves, those disturbances in the fabric of space-time that Einstein predicted. The connection between these phenomena is an active area of research that could revolutionize our understanding of gravity and the nature of the universe. Popular culture has begun to draw attention to these cosmic phenomena. Movies, books, and science fiction series have begun to incorporate the idea of magnetars, although often with a more fantastic than scientific approach. This raises questions about how we perceive these objects in society, and how cultural representations can influence our understanding of science. As we delve into the world of magnetars, it is important to recognize the challenges that scientists face. Studying these objects is no easy task. The distance, the intensity of their magnetic fields, and their ephemeral nature are just some of the obstacles that must be overcome. However, each advance in this area of study brings us one step closer to unveiling the secrets of the universe. The search for answers about magnetars is ultimately a quest for knowledge. We wonder what they can teach us about life, death, and the evolution of the cosmos. Each discovery about these extreme cosmic magnets reminds us that there is still much to learn and explore in the vast and mysterious universe we inhabit. With each new revelation, we begin to better understand our place in the cosmos and the complexity of nature itself. Magnetars are fascinating and mysterious, but what exactly are they? Imagine a star that not only shines with intense light, but also possesses a magnetic field so powerful it could have devastating effects on its surroundings. At the heart of a magnetar, gravity and magnetism are in a cosmic struggle, creating an object that defies our understanding of physics. This combination of features makes magnetars unique among neutron stars, and their study opens a world of intriguing questions. A neutron star, in general, is the collapsed remnant of a massive star after a supernova explosion. But magnetars take this concept to a new level. What makes them so special? The answer lies in their magnetic field, which can be 1,000 trillion times stronger than that of Earth. To put this in perspective, if a magnetar were only 10,000 kilometers from our planet, it could wreak havoc on our electronic devices and disrupt the functioning of compasses. It's not just strong magnetism, it's extreme magnetism. Now, how are these magnetic titans formed? In simple terms, magnetars arise when a massive star exhausts its nuclear fuel, collapsing under its own gravity. However, not all neutron stars become magnetars. They are believed to be the result of a very specific magnetization process that occurs during the supernova explosion. In this scenario, the magnetic fields that are generated can be intensified to reach extreme levels, giving rise to what we know as a magnetar. But what about their appearance? Magnetars are not just bright neutron spheres, they possess a complex internal structure. At their core, dense particles cluster together, creating an environment where physics behaves in ways we do not yet fully understand. Imagine a giant magnet, but instead of being an everyday object, it's a cosmic colossus located in deep space, generating energy pulses that resonate across the universe. The story of magnetars is intertwined with that of their magnetic field. This is not just any field, it is known as an extreme strength magnetic field. The way we measure this field is fascinating. We use X-ray telescopes, which capture the radiation emitted by these objects to understand their intensity. Through these studies, scientists have been able to determine that the magnetic field of a magnetar could, in theory, warp the space-time around it. But how does this translate into something we can imagine? Think of a magnet that, when approaching metal, attracts it with unexpected force. Now imagine that this force is so intense it could distort everything around it. This is the kind of power magnetars possess, and their influence extends far beyond their own existence. Their magnetic field can alter matter in their vicinity, affecting everything from cosmic gas to other nearby stars. The interaction between the magnetar and its environment is a cosmic ballet, where gravity and magnetism play a crucial role. When talking about magnetars, we cannot forget gamma-ray bursts, one of the most spectacular phenomena in the universe. These bursts are like extremely powerful flashes of light that can be seen millions of light years away. They are believed to be related to the activity of magnetars, and their study not only helps us understand these objects, but also provides clues about the cataclysmic events that occur in the cosmos. Did you know that a single gamma-ray burst can release more energy than our Sun will emit in its entire lifetime? X-ray pulses are another distinctive feature of magnetars. These pulses are like beats of a cosmic heart, and their study offers us a window into the interior of these mysterious objects. Each pulse gives us valuable information about the structure and composition of the magnetar, helping us unravel its secrets. But what do these pulses really tell us about the life of a magnetar? Comparing a magnetar to a common neutron star is like comparing a race car to a family vehicle. While both are impressive in their own way, magnetars stand out for their extreme magnetism and their ability to generate astonishing cosmic phenomena. In this sense, magnetars are the superheroes of the universe, performing feats that defy our understanding. The life of a magnetar is equally fascinating, from their formation after a supernova explosion to their eventual disappearance. These objects have a life cycle that can last thousands of years. Throughout this time, their magnetic activity and energy explosions contribute to the evolution of the cosmos. Who could imagine that such a powerful and enigmatic being could arise from the death of a massive star? In conclusion, magnetars are more than just neutron stars. They are the magnetic titans of the universe. Their power, their mystery, and their influence on the cosmos remind us of how little we know about the universe that surrounds us. As we explore more about these fascinating objects, each discovery brings us one step closer to understanding the secrets of the cosmos. So, the next time you look up at the sky, remember that there could be a distant magnetar generating its formidable energy and leaving its mark on the vast theatre of the universe. In the vast and mysterious universe, stars are not just bright points in the sky. Some of them, like magnetars, are true cosmic wonders that invite us to explore their extraordinary nature. How do these magnetic colossi form, and what secrets do they hold about their origin? The story of a magnetar begins with a massive star that has exhausted its nuclear fuel. When the heart of this star collapses, a supernova explosion occurs, an event so powerful it can light up the night sky for days. But not all exploding stars become common supernovas. Some of them give life to magnetars, neutron stars with incomprehensibly strong magnetic fields. But what exactly is a magnetar? Imagine having a magnet that is millions of times stronger than any magnet you have ever known. At its core, a magnetar contains an incredible amount of compressed matter. A single cubic centimetre of its surface could weigh as much as an elephant. This incredible density is the result of gravity and extreme pressure generated at the end of a massive star's life. As this star flattens and contracts, its magnetic field intensifies, turning it into a true magnetic titan. The formation process of a magnetar is like a dramatic life cycle. After a massive star exhausts its fuel, its core collapses and heats up so much that it generates an energy explosion. This explosion can be so colossal that it throws the star's material into space, while the remaining core becomes a neutron star. The fascinating thing is that, in the case of magnetars, the collapse not only produces a neutron star, but also amplifies its magnetic field, for reasons scientists are still trying to understand. Now, what makes these magnetic fields so special? The intensity of a magnetar's magnetic field can be a quadrillion times stronger than that of Earth. To put it in perspective, if you brought a magnetar close to our planet, its magnetic fields could affect not only compasses, but also the electrical and electronic systems we use daily. This phenomenon triggers a domino effect in the surrounding space, even affecting the behavior of matter in its proximity. Measuring these fields is a challenge. Scientists use telescopes and other advanced tools to detect the radiations emitted by magnetars. This is similar to how a doctor might use a scanner to examine the human body. With each pulse and emission, astronomers manage to unravel a little more about the structure and nature of these fascinating objects. When talking about magnetars, their influence on their environment cannot be ignored. Extreme magnetic fields can cause phenomena like gamma-ray bursts and X-ray pulses, which are signals scientists use to study the behavior of these celestial bodies. But how do these events affect other stars or even nearby planets? The answer lies in the interaction of magnetic forces, which can alter the structure of matter and create unimaginable conditions. Magnetars have a relatively short lifespan compared to other stars. Their intense magnetic activity and explosions can lead to rapid transformation. This raises an intriguing question. How long can a magnetar survive before its energy runs out? While its life cycle is fleeting, its impact on the universe is lasting. When we look at the sky and see a flash of light, it could be the last breath of a magnetar on its journey towards extinction. The evolution of a magnetar is not only fascinating for its process, but also for the implications it has for the formation of new stars. As a magnetar disintegrates, it can contribute to the material needed to create new stars and planetary systems. This life and death cycle is a reminder of the interconnection that exists in the universe. Stars are born and die, and in this process they create the conditions for new lives to emerge. In our own galaxy, the Milky Way, several magnetars have been identified. Their distribution is not random. These magnetic titans are found in regions where massive stars have exploded. The search for magnetars in our galaxy helps us better understand the history of star formation and galactic evolution. How do these objects relate to the structure of our galaxy? The relationship of magnetars with modern physics, especially Einstein's theory of relativity, is another fascinating aspect. Relativity teaches us that gravity and magnetism are intertwined in unusual ways, and magnetars are natural laboratories where these principles can be observed in action. As we learn more about these objects, we are also unraveling the mysteries of space and time. Exploring magnetars is not just a scientific task, it also raises profound questions about our existence. What can they teach us about the universe as a whole? As we continue to investigate these cosmic phenomena, we discover that magnetars are more than just stars. They are windows into understanding the very nature of the cosmos. Finally, it is crucial to continue researching. Future missions and telescopes are designed to delve deeper into the study of magnetars, seeking answers to questions that still elude us. Each discovery about these extreme cosmic magnets not only enriches our understanding of the universe, but also connects us with the legacy of science and the eternal human curiosity for the unknown. In the end, magnetars are not only a testament to the beauty of the cosmos, but also an invitation to continue exploring and questioning what surrounds us. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey. Have you ever stopped to think about the power of a magnet? Yes, those small objects we have at home, which can hold notes on the fridge or join two pieces of metal. Now, imagine a magnet that not only holds a piece of paper, but has the ability to alter matter around it, even light years away. This is what happens with magnetars, stars that are, in essence, extreme cosmic magnets. But how extreme are their magnetic fields? The intensity of a magnetar's magnetic field is truly astonishing. To give you an idea, those small magnets we know have magnetic fields that hover around milligauss. In contrast, a magnetar can have a magnetic field that exceeds 1 billion Gauss. That's like comparing the force of a gentle breath of air with that of a hurricane. The immensity of their magnetic field is not only fascinating, but also has profound and often baffling effects on the space around it. Measuring these fields is not a simple task. Astronomers use advanced technology to detect signs of these magnetic fields. Often, they resort to telescopes that can capture electromagnetic radiation at different wavelengths, from radio to X-rays. But why is it so crucial to understand the magnitude of these fields? The answer lies in how these fields interact with matter and radiation in space. When a magnetar emits a pulse of X-rays, that radiation can be influenced by its magnetic field. Imagine throwing a ball in a force field. The trajectory of the ball is affected by the force acting on it. In the same way, the radiation emitted by a magnetar can be deflected or altered by its powerful magnetic field. This means that every time we observe a magnetar, we are not only seeing the star itself, but also the effect of its magnetic field on the universe around it. The effects of these fields do not stop there. It has been observed that magnetars can generate extremely powerful stellar winds, capable of dragging and distorting the matter around them. Imagine a giant fan that not only blows air, but also drags everything in its path. This can have a significant impact on interstellar gas and dust, influencing the formation of new stars and the evolution of galaxies. But what happens when a magnetar enters an active phase? During these periods, astonishing phenomena occur. The gamma-ray bursts that are associated with magnetars are often the result of the sudden release of magnetic energy. This process is so powerful that it can generate gamma-ray flashes that are brighter than an entire galaxy. These flashes are a reminder of the immense energy they can generate and the extraordinary nature of these objects. The interaction between a magnetar's magnetic field and its environment can also cause changes in the structure of nearby matter. For example, the field can distort space-time itself, creating an effect that could be compared to that of a massive object, like a black hole. This phenomenon is something that scientists continue to investigate, as it may offer clues about how the universe works as a whole. A fascinating aspect of magnetars is how their magnetic field can influence time and space. As matter is affected by these fields, it can experience changes in its atomic structure, which can lead to the creation of new types of particles. This opens up a world of possibilities about how magnetars could contribute to our understanding of fundamental physics. It's amazing to think that these extreme magnetic fields are not just a scientific curiosity, but also have the potential to provide us with information about the origins of the universe. Every time we observe a magnetar, we are looking at a window into the processes that shape the stars and galaxies we see today. In this sense, magnetars are like cosmic fossils, preserving the history of the universe in their intense magnetic fields. The ability of magnetars to influence their environment also raises intriguing questions about how they might interact with other stars and planets. If a magnetar were relatively close to our solar system, how would it affect Earth? The answers to these questions are not only relevant to astrophysics, but also lead us to reflect on our place in the universe. As we continue to explore the cosmos, magnetars present themselves as a promising field of study. Each finding about their magnetic fields and behavior brings us one step closer to understanding not only these stars, but also the mechanisms that govern the universe. Human curiosity and the desire to understand the unknown are what drive us to keep exploring and learning. So the next time you think about a magnet, remember that there are magnets in the universe that are much more powerful and fascinating than we could imagine. Magnetars, with their extreme magnetic fields and their effects on the cosmos, remind us that the universe is full of mysteries waiting to be discovered. In each pulse of X-rays and each flash of gamma rays, there is a story to tell and knowledge to acquire. Magnetars, those fascinating cosmic objects, are not just neutron stars but possess a magnetic field so intense that it defies our understanding. But what effects do these extreme magnetic fields have on their surroundings? How do they interact with the space around them? The answer to these questions is both intriguing and astonishing. First, let's consider the strength of a magnetar's magnetic field. To put it into perspective, imagine a common refrigerator magnet. Now, multiply that force by millions. Magnetars have magnetic fields that can reach levels of 10 to the power of 15 Gauss, a figure that is approximately a quadrillion times stronger than Earth's magnetic field. To better understand, if you were near a magnetar, you could see how metal is drawn to it as if it were a mere piece of paper flying in a gust of wind. The intensity of these fields is not only astonishing, it also has profound effects on the matter around it. For example, electrons, which normally move freely in space, are forced to change their trajectory and speed. In a magnetar, these electrons behave as if they were on a dance floor, but not just any dance floor. It's a floor that spins and twists chaotically. This phenomenon has a name, magnetohydrodynamics, which might sound complicated, but it refers to how magnetic fields influence the movement of plasma, the state of matter that makes up most of the universe. The effects of these magnetic fields are not limited to the matter near the magnetar. In fact, they can even affect space-time itself. Can you imagine a magnet so powerful that it not only attracts objects but also distorts reality around it? Magnetars have the ability to alter the environment in their vicinity, generating particle currents that can be detected at great distances. But what about light rays travelling near a magnetar? Light, that thing that normally travels in a straight line, is affected. In the presence of such a strong magnetic field, photons, which are light particles, can change their direction. This phenomenon is known as birefringence, and it means that light behaves differently when passing near a magnetar. Essentially, a magnetar can act as a cosmic prism, splitting light and changing its path. The effects also extend to the radiation emitted by the magnetar. When a magnetar is active, it emits pulses of X-rays and radio waves that are a direct result of its powerful magnetic field. This radiation can be so intense that if you are in the vicinity of a magnetar, the radiation levels could be lethal. However, thousands of light years away, these pulses become valuable tools for astronomers who can study them to better understand the nature of these mysterious objects. Not only is radiation affected, even the environment can be altered by the energy explosions that occur on the surface of a magnetar. These explosions, known as flashes, release colossal amounts of energy that can ionize atoms in the surrounding space. Imagine these explosions as cosmic fireworks, illuminating space and leaving a trail of charged particles that can interact with other celestial bodies. Magnetars also have an impact on the interstellar medium. Explosions and energy pulses can push the gas and dust of space, creating shock waves that can influence the formation of new stars. Thus, although a magnetar may seem like a distant and isolated phenomenon, in reality its influence can contribute to the creation of new generations of stars and planets. And although it might seem that magnetars are simply inert objects, in reality they are very active. Their activity can be unpredictable, and this increases scientists' interest. Every time a magnetar emits a pulse or an explosion, researchers have the opportunity to learn more about these mysterious giants. Constant observation of their behavior helps astronomers build a clearer map of how our galaxy works. On a deeper level, magnetars also teach us about the limits of physics, challenging our theories and leading us to reconsider what we know about gravity, matter, and energy. Each discovery about magnetars opens new questions that lead us to explore even further. What else could we learn from these mysterious objects floating in the heart of our universe? None of this would be possible without the advanced technology we have today. Telescopes and satellites designed to study X-rays and radio waves allow us to capture the energy flashes emitted by magnetars, and each pulsar is like a signal on a cosmic radio that we can tune into. The ability to observe and analyze these emissions gives us a window into the processes occurring in space and allows us to visualize the universe in a completely new way. The complexities of magnetars force us to rethink our understanding of the cosmos. Could it be that by studying these objects we are touching the tip of the iceberg of a much deeper knowledge about the universe? The relationship between magnetism and matter, between the visible and the invisible, invites us to keep asking and exploring. In conclusion, The magnetic fields of magnetars are a phenomenon that transcends what we can imagine. With their ability to influence space and matter, they offer us a fascinating lesson about the forces that shape our universe. So, as we continue observing and learning, let's remember that each magnetar is a story in itself, a reminder of the complexity and beauty of the cosmos we inhabit. Gamma-ray bursts are one of the most fascinating and enigmatic phenomena in the universe, and magnetars are the protagonists in many of these events. But what exactly are these bursts, and why are they so closely linked to magnetars? To understand this, we first need to think about energy. Imagine a shaken soda bottle. When you uncap it, the built-up pressure is suddenly released, creating an explosion of bubbles. In the cosmos, this same principle applies, but on an unimaginable scale. Magnetars, with their powerful magnetic fields, store a colossal amount of energy. In fact, their magnetic field is so intense that, in just an instant, it can release more energy than the sun in its entire lifetime. But how is this energy release triggered? The answer lies in the unusual behavior of matter inside a magnetar. As the star cools and its surface cracks, these fractures can release enormous amounts of energy in the form of gamma rays. This is similar to a bag of popcorn popping when the heat makes the internal pressure too high. The gamma-ray flashes we observe from Earth are, in essence, alarm signals from these cosmic giants. When a magnetar emits a gamma-ray burst, it is an extremely brief but explosive event. These explosions can last from milliseconds to several minutes, and their brightness can be so intense that they can be detected billions of light years away. Imagine you're in a dark forest and suddenly, someone lights a firework. The light is so bright that it illuminates everything around it, even before you can hear the bang. This is how these explosions reach us from deep space. But why is it important to study these explosions? The answer is that they offer us a window into the behavior of matter under extreme conditions. When a magnetar bursts, the gamma rays it emits provide us with information about its internal composition and structure. This knowledge is vital for understanding not only magnetars, but also the physics that govern the universe in general. Each flash is like a coded message that scientists must decipher. Furthermore, gamma-ray bursts not only tell us about magnetars, but they also allow us to observe events that occurred billions of years ago. By studying these phenomena, we can learn about the history of the universe, how galaxies formed, and how stars have evolved over time. It's as if we could look back in time by receiving a message from an ancient civilization. However, there's more at stake. The energy released during these explosions can have effects on their immediate surroundings. Gamma rays are highly energetic and can ionize matter, meaning they can break chemical bonds and alter the composition of nearby gases. This could influence the formation of new stars and consequently the evolution of galaxies. So in a sense, magnetars are not only destroyers, but also creators in the vast cosmic theatre. The chaotic nature of these explosions also raises questions about their frequency and distribution. How often do these events occur? Astronomers have recorded thousands of gamma-ray bursts, but not all come from magnetars. Some come from supernova explosions, while others are the result of neutron star mergers. Each of these events has its own unique signature. allowing scientists to trace their origin and nature. Now, detecting these bursts is not a simple task. Gamma-ray bursts are extremely brief and can occur anywhere in the sky. However, thanks to advances in technology and specialized telescopes, scientists have been able to catalogue and study these events in detail. Each new burst offers the opportunity to learn something new, like finding a needle in a cosmic haystack. The study of magnetars and gamma-ray bursts has also led to the creation of new theories in astrophysics. The way these cosmic giants behave can challenge our previous notions of physics. For example, gamma-ray bursts that occur in magnetars have led scientists to reconsider certain aspects of relativity theory and quantum physics. Each discovery is a step towards a deeper understanding of the universe. Lastly, it's essential to mention that magnetars, although they are millions of light years away, remind us of our connection with the cosmos. Each gamma-ray burst we observe is a reminder that the universe is a place full of mystery and wonder. These phenomena not only extend our boundaries of knowledge, but also make us reflect on our own existence in this vast and enigmatic reality. So the next time you hear about a magnetar and its gamma-ray bursts, remember that behind each flash is an opportunity to learn more about the universe and our place in it. Each of these events is a spark in the darkness, illuminating the path to new questions and discoveries. In the vast and mysterious universe, magnetars are true cosmic wonders that offer us a glimpse into extraordinary phenomena. But what exactly are the X-ray pulses they emit? To understand this, we must first know that a magnetar is a special type of neutron star. And like a lighthouse in the darkness, they emit flashes of extremely intense radiation. X-ray pulses are like intermittent signals that come from these objects. Imagine a flashlight that, instead of emitting continuous light, flashes at intervals. But we are not talking about a common flicker. In the case of magnetars, these pulses are so powerful that they can be detected from billions of light years away. This means that when we see these flashes, we are looking into the past at events that occurred eons ago. What are these X-rays made of? Essentially, they are high-energy photons that are generated on the surface of the magnetars, where gravity is so intense that electrons are accelerated to extraordinary speeds. This phenomenon is comparable to how a car can accelerate quickly on a highway. In this case, the highway is the extreme magnetic field of the star. But what happens when these electrons reach speeds close to light? A chain reaction occurs, releasing an incredible amount of energy in the form of X-rays. Now, not all magnetars are the same. Some are more active than others, which means they emit X-ray pulses more frequently. This variable behavior is fascinating for astrophysicists, who see it as a window into the internal dynamics of these stars. Each pulse we detect can tell us something about the internal structure of the magnetar, as if we were listening to the beat of a cosmic heart. What information do these pulses provide us? Variations in the frequency and intensity of the X-rays can reveal details about the magnetic field and rotation of the star. As a magnetar spins, its magnetic field can interact with its environment, causing shock waves to be generated that translate into those pulses we capture in our telescopes. It's as if the magnetar is sending an SOS to the universe, allowing us to decipher its history and composition. Sometimes, X-ray pulses can be so intense that they even turn into explosions. These explosions, known as bursts, are brief but extremely powerful events that can release more energy than our Sun emits in its entire lifetime. These bursts are a reminder of the violent and energetic nature of magnetars, and their study can help us better understand energy release processes in the cosmos. Some scientists have compared the study of X-ray pulses to listening to music in a room full of instruments. Each instrument has its own tone and rhythm, and when they all play together, they create a symphony. Similarly, the pulses we receive from magnetars can be analysed to reveal the melody of their activity, allowing researchers to identify patterns and anomalies that can offer clues about their behaviour. The relationship between a magnetar's rotation and its pulses is also an intriguing aspect. As it spins, the magnetar can accelerate the emission of X-rays, producing rhythmic pulses and sometimes even unexpected variations. This leads us to wonder, are these pulses a form of communication, or simply a manifestation of the extreme physics that govern their existence? The answer is still up in the air, but the study of these pulses is one of the keys to unraveling the secrets of these stars. X-ray pulses are not only interesting in themselves, but also serve as tools for the study of space. By analysing these rays, astrophysicists can learn about dark matter and dark energy that make up most of the universe. It's as if magnetars were lighthouses illuminating the path to understanding, guiding us in our search for answers about the cosmos. One of the most intriguing questions that arise is, how can these pulses affect their environment? The answer lies in the interaction of their magnetic fields with the surrounding space. These pulses can influence nearby matter, generating effects that go beyond what we can imagine. As the X-rays propagate, they can alter the structure of gas and dust clouds, affecting the formation of new stars. Although magnetars are extremely distant objects, their impact is felt in our quest for knowledge. Each pulse we receive is an opportunity to learn more about the boundaries of the universe and the laws that govern it. The question is, what other secrets could they reveal to us in the future? The answer lies in ongoing research and the unquenchable curiosity of scientists. As we delve deeper into the relationship between X-ray pulses and magnetars, we realize that each discovery brings us closer to understanding not only these stars, but also the very nature of the universe itself. In each flash, there is a story waiting to be told, and each story connects us more with the cosmos. In summary, the X-ray pulses emitted by magnetars are one of the most fascinating manifestations of modern astrophysics. By studying these pulses, we are not only unraveling the mysteries of magnetars, but also expanding our knowledge about the universe and our place in it. The exploration of these phenomena is not just a journey into the unknown, it's a reminder that there is always more to discover in the vast and exciting cosmos we inhabit. When we think about neutron stars, we often conjure up images of extremely dense and compact objects, but magnetars take this idea to a new level. What makes them so special compared to other neutron stars? The answer lies in their incredible magnetic field. Magnetars are like the superheroes of the universe, with magnetic powers that far surpass those of their close relatives. A magnetar can have a magnetic field that is 1,000 times stronger than that of a typical neutron star. To put this into perspective, imagine a refrigerator magnet. The magnetic field of a normal magnet is strong enough to hold some notes on your fridge. Now, imagine a magnet so powerful that it could hold up an entire building. That's the magnitude of a magnetar's magnetic power. But why is this magnetic force so significant? The answer lies in how it affects its surroundings. While a conventional neutron star has a strong magnetic field, a magnetar can distort the space around it, as if it were manipulating the rules of gravity. This causes extraordinary phenomena, like gamma-ray bursts that make us wonder how nature can be so spectacular. Now, if we compare a magnetar with another type of neutron star, we start to see fascinating differences. Neutron stars are formed by the collapse of massive stars, but most of them have magnetic fields that, while intense, are not extreme. Magnetars, on the other hand, are a special kind of neutron star that has a magnetic field generated in a different way, giving them their unique characteristics. In a way, they are like an upgraded version of their counterparts. Moreover, a magnetar's life is shorter and more explosive. While a neutron star can exist for millions of years, a magnetar has a more tumultuous life cycle. This is because its intense magnetic field can cause instability, resulting in energy explosions that can be observed from thousands of light years away. It's as if you had a star that not only shines but also launches cosmic fireworks. When thinking about these differences, an intriguing question arises. How can we study these distant phenomena? Astronomers use telescopes that detect X-rays and gamma rays. These tools are like the eyes of the universe, capable of seeing what is beyond what our eyes can perceive. Thanks to these observations, we have been able to learn a lot about the nature of magnetars and their behavior. The gamma-ray bursts associated with magnetars are one of the most fascinating features. These eruptions are like beacons that illuminate the darkness of space, revealing crucial information about the life of these celestial objects. Every time a magnetar explodes, it sends out an energy wave that can be picked up by telescopes on Earth, allowing us to study its composition and internal structure. As we delve deeper into the study of magnetars, we also begin to understand how they relate to other astrophysical phenomena. For example, it has been discovered that magnetars can influence the formation of new stars in their vicinity. Their intense magnetic field can compress clouds of gas and dust, creating the necessary conditions for new stars to be born. It's as if they were the architects of the cosmos, shaping the matter around them. At this point, many will wonder, what role do magnetars play in the evolution of the universe? The answer is that they are key players in the life cycle of galaxies. Their energy not only affects other celestial objects, but can also influence the way galaxies develop over time. This impact can be significant, making magnetars more than just astronomical curiosities. They are fundamental to understanding the universe as a whole. As new theories are developed and more research is conducted, questions also arise about the future of these mysterious objects. Could magnetars teach us something about the nature of gravity and space-time? What secrets do they still hold? Each answer we find opens the door to new questions, and that's what makes science so exciting. The comparison between magnetars and other neutron stars not only highlights their magnetic differences, but also shows us how varied and surprising nature can be. Each discovery about these cosmic objects brings us closer to better understanding the mechanisms of the universe and how everything is interconnected. Finally, when thinking about magnetars, it's hard not to marvel at the forces that govern the cosmos. These phenomena are not only fascinating from a scientific point of view, but they also remind us of how small we are compared to the vastness of the universe. The search for answers about magnetars is ultimately a search for ourselves, for our place in the cosmos, and for understanding the forces that surround us. The next time you look up at the starry sky, remember that, in some corner of the universe, these magnetic giants exist that defy our understanding and invite us to keep exploring the mysteries of space. The life of a magnetar is a fascinating journey full of surprises. For many, it can be hard to imagine how the existence of a star can be so fleeting and yet so powerful. But what is the life cycle of a magnetar? What stages does it go through in its existence in the vast cosmos? Everything begins with a massive star, a giant that has lived a life full of nuclear fusion in its core. For millions of years, this star shines brightly, creating heavier elements as it consumes its hydrogen. But at the end of its life, a critical moment arrives. The fuel runs out and the star faces its destiny. In a final act of grandeur, this star explodes in a supernova, a cataclysmic event that can eclipse the light of an entire galaxy. However, instead of fading away, what remains is a fascinating remnant, a magnetar. Once the supernova has occurred, the core collapses under its own gravity. At this point, conditions are extreme. The pressure and temperature are so high that electrons and protons combine to form neutrons, creating a neutron star. But not all neutron stars are the same. Some, like magnetars, possess an incredibly strong magnetic field, millions of times more powerful than that of a common refrigerator. This magnetic field originates from the rapid rotation of the star and the complex dynamics in its core. But how long can a magnetar last in this stage of its life? The answer is surprising, only a few thousand years. Despite their incredible power, magnetars are not eternal. Their lifespan is like a bright flash in the darkness of space, an impressive spectacle that ends quickly. As the years pass, the magnetic field begins to weaken, and the magnetar becomes what is known as a normal neutron star. However, during its short existence, a magnetar can have a monumental impact on its surroundings. During their active phase, magnetars can generate gamma-ray bursts and X-ray pulses, events that are like cosmic fireworks. But why are these explosions so important? The energy released in these events can be so intense that it can affect nearby matter and in some cases even influence the formation of new stars. Imagine a spark that ignites a fire. That's how powerful a magnetar's influence on its surroundings can be. Despite their short life, magnetars are fascinating objects of study for astrophysicists. They provide us with valuable information about physics under extreme conditions and help scientists better understand the universe, the way a magnetar interacts with its surroundings, how it affects other stars, and how its energy explosions propagate through space gives us clues about the mysteries of the cosmos. It's interesting to think that, although magnetars have a short life, their legacy is enduring. The gamma-ray bursts they emit can be detected billions of light-years away and can provide data on the expansion of the universe itself. In this sense, magnetars are like messengers of the cosmos, carrying information through time and space. As a magnetar ages, its magnetic field weakens and it loses some of its energy. It becomes a normal neutron star, although it can still have a strong magnetic field, just not as extreme as before. This process can be similar to an athlete who, after years of competing at the highest level, retires. Although they are no longer at their peak, their experience and contributions to the sport remain valuable. Throughout its life, a magnetar can also change its position in the galaxy. As it interacts with its surroundings, it can be influenced by the gravity of other stars and black holes. This movement can take it to unexpected places, becoming a space traveler, carrying the history of its formation and evolution. The death of a magnetar is equally fascinating. Eventually, it will stop emitting energy and cool down, becoming a more inert object. Although its activity decreases, its essence remains in the fabric of the universe, reminding us of the fleeting beauty of stellar life. Thus, the life cycle of a magnetar is a reminder that even the most powerful objects in the universe have a limited existence. They are born in supernova explosions, shine brightly for a short period, and finally they fade away. However, their effects and their influence on the cosmos continue long after their light has disappeared, leaving a legacy that endures through time and space. In the end, the life of a magnetar is an extraordinary journey, full of energy and transformation. It teaches us about the nature of the universe and reminds us that, in the vast cosmos, every star has its own story to tell. In the vast ocean of our galaxy, magnetars are like bright gems but extremely rare. It is estimated that there are approximately 20 known in the Milky Way, although there could be many more that we have not yet discovered. Can you imagine finding a star that not only shines, but also has a magnetic field so intense that it defies all the laws of physics we know? This is what makes magnetars so fascinating. Most of the identified magnetars are the result of supernova explosions, that spectacular end of life of massive stars. But where exactly are these cosmic objects located? For the most part, magnetars are distributed in regions where star formation is active, such as in young clusters. Like jewels in a showcase, they can sometimes be hidden among the multitude of stars that surround us. One of the most well-known magnetars is called SGR-003, located about 20,000 light-years away from our home. This magnetar has been the protagonist of fascinating events, such as gamma-ray bursts that have left astronomers astonished. But what does this mean for us? The distance that separates us from them gives us a unique perspective. Although they are far away, their energy and activity reach us in the form of light and radiation, allowing us to study their mysteries. The location of magnetars also has implications in the evolution of galaxies. Being such dense and powerful objects, their influence can alter the matter that surrounds them. Imagine throwing a stone into a calm pond. The waves that are generated affect the entire environment. The same happens with magnetars, which can affect the formation of new stars through their magnetic fields and explosions. In addition, there is a notably interesting magnetar called X1902, which is located right in the heart of the Milky Way. This magnetar is a reminder that even in the core of our galaxy, where gravity is intense and the environment is chaotic, magnetars can exist and create their own cosmic history. What other secrets might our galaxy be holding? The diversity of magnetars is also surprising. Some may be older and less active, while others are young and extremely bright. This variety offers us a window into different stages of life of these objects. As if they were chapters of a book, each magnetar tells a different story about stellar evolution and the fate of massive stars. But what about the way scientists have managed to identify these magnetars? Modern technology has allowed astronomers to detect the radiation they emit, as well as the gamma ray bursts they generate. Each time a magnetar emits a pulse of X-rays or gamma rays, it's like a distress signal from deep space, calling us to study and understand what's happening there. Magnetars are not only fascinating in their nature, but also in what they represent as the context of the universe. Each one of them is a reminder that there are forces and phenomena that we have yet to discover that challenge our current understanding of physics. What other secrets of the cosmos might be hidden in the darkness? The distribution of magnetars also raises questions about how they formed and how they cluster in the galaxy. Some theories suggest they may be related to star-forming zones, where massive stars are born and die in spectacular explosions. This means that by studying magnetars, we could gain valuable insight into the history of our galaxy and the life cycle of stars. In our quest to understand the universe, magnetars are like beacons in the night, guiding us towards deeper knowledge. Through their study, we not only learn about these particular objects, but also about the processes that govern the life and death of stars. How do magnetars fit into the grand puzzle of the cosmos? The search for magnetars has also led to the creation of specialized telescopes and space missions, venturing into the darkness of space to capture their light and radiation. These instruments are like treasure hunters, equipped with the necessary technology to detect the flashes of energy emitted by these enigmatic objects. Each new discovery brings us a little closer to understanding their nature and their impact on the universe. The importance of magnetars is not limited to their fascinating existence. They also teach us about life in the cosmos and the extremes to which matter can go. By understanding how they work, we can begin to decipher the mysteries of modern physics and how they relate to our own world. What lessons could we learn from these extreme cosmic magnets? In conclusion, the search and study of magnetars in the Milky Way is not only a journey through space, but also an exploration of the limits of human knowledge. Each magnetar we discover is a new opportunity to learn about the nature of the universe and our place in it. In this vast and mysterious cosmos, magnetars are a reminder that there is always more to discover, and that each answer can open the door to new questions. When we think about magnetars, it's easy to get carried away by their extraordinary nature. But how do they relate to Einstein's theory of relativity? To understand this, we must first remember that relativity tells us that space and time are not separate concepts, but are intertwined in what is known as space-time. This intertwining becomes a canvas upon which the events of the universe are drawn. Imagine a trampoline. When someone sits in the center, the fabric sinks. This deformation is similar to how the mass of an object like a magnetar affects the space-time around it. A magnetar, being a neutron star with an extremely intense magnetic field, not only has significant mass but also distorts space-time in a way that can be fascinating. The magnetic field of a magnetar is so strong that it can influence the path of light, something that is a central concept in relativity. Now, what does this mean in terms of gravity? Relativity tells us that gravity is not just a force, but a curvature in space-time. A magnetar, with its dense mass and magnetic field, acts like a kind of hole in that trampoline of space-time. This not only affects nearby objects, but its influence can extend to much greater distances, affecting the trajectory of other celestial bodies. And what about gravitational waves? When two massive objects like two magnetars orbit each other, they create disturbances in space-time that propagate as waves. These waves are like the waves that form in a pond when you throw a stone. The detection of gravitational waves has revolutionized our understanding of the universe and has opened a new window to study extreme events and cosmic phenomena like magnetars. Gravitational waves tell us stories about cataclysmic events occurring in the cosmos. When a magnetar collides with another massive object, the release of energy is immense, and the resulting gravitational waves can be measured by high-precision instruments. This allows us not only to observe magnetars, but also to better understand their behavior and their role in the universe. But how do these phenomena relate to modern physics? Einstein's theory of relativity has been fundamental in explaining how gravity behaves in the presence of massive objects. As scientists study magnetars, they realize that these extreme objects can test the limits of our current understanding. The extreme conditions found near a magnetar may reveal new properties of gravity and could even challenge our existing theories. The connection between magnetars and relativity also leads us to think about how these magnetic phenomena affect the light travelling around them. The light passing near a magnetar can be deflected, causing strange and exciting visual effects that astronomers can study. These interactions between light and a magnetar's gravitational field are an active area of research and help us understand how physics works under extreme conditions. When exploring these concepts, it is crucial to remember that relativity is not just an abstract theory, but a powerful tool that helps us unravel the mysteries of the universe. Magnetars, with their intense magnetic fields and incredible mass, are natural laboratories where we can observe relativity in action. Each new discovery about these cosmic objects brings us one step closer to understanding how the universe works as a whole. The relationship between magnetars and relativity also invites us to consider the future of scientific research. As we advance in our understanding of physics, magnetars will continue to be fundamental in answering questions about the nature of space, time, and gravity. The search for answers to these questions is an exciting journey that continues to reveal the beauty and complexity of our universe. As we reflect on everything we have learned, it is essential to recognize that each discovery about magnetars is not just a breakthrough in astrophysics, but a window into understanding ourselves and our place in the cosmos. Magnetars, with their extraordinary nature, remind us that there is still much to explore and understand in the vast universe we inhabit. So, when thinking about magnetars and their relationship with relativity, let's remember that we are dealing with a phenomenon that is not only fascinating in itself, but also has the potential to change our fundamental understanding of physics and the universe. With each new observation and each new theory, we move closer to a future full of exciting and revealing discoveries. Magnetars are not only fascinating due to their extreme magnetism, but they are also closely related to phenomena that challenge our understanding of the universe. One of the most intriguing connections is the one they have with gravitational waves. But what exactly are gravitational waves, and why should we care about them in the context of magnetars? Gravitational waves are like waves in water, but instead of being caused by a stone thrown into a lake, they are generated by massive events in the universe, such as black hole collisions or star explosions. When these events occur, the fabric of space-time warps, creating waves that travel across the cosmos. And this is where magnetars come into play. Their intense gravity and magnetic fields can influence the production of these waves, making their study crucial to understanding both magnetars and the very structure of the universe. Imagine you're at a party and suddenly two people start to dance very energetically. Their movement not only affects the immediate space around them, but also causes waves that spread throughout the room. Similarly, when a magnetar emits energy or interacts with its environment, it can generate gravitational waves that travel through space, allowing us to hear what is happening thousands of light years away. The question is, how can we hear these waves? Through extremely sensitive detectors, like the LIGO Observatory, which made history by capturing gravitational waves for the first time in 2015. This type of technology can record the tiny disturbances these waves produce as they pass through Earth. The challenge is that, although gravitational waves are fascinating, they are incredibly difficult to detect, making them an exciting and challenging field of study. Now, what is the relationship between magnetars and these waves? Magnetars, with their powerful rotation and extreme magnetic fields, can be sources of energy explosions that, under certain conditions, could generate gravitational waves. These explosions, known as gamma-ray bursts, are cataclysmic events that can release more energy in a few seconds than the sun will emit in its entire lifetime. When a magnetar experiences such an event, it can send gravitational waves through space, allowing us to capture information about its nature and behavior. But why is it so important to study these gravitational waves in relation to magnetars? The answer is simple. By understanding how and when these waves are produced, we can gain clues about the internal structure of magnetars and the physical processes taking place inside them. Gravitational waves act as a kind of listening to the universe, revealing secrets that would otherwise remain hidden to our telescopes. Furthermore, studying the gravitational waves generated by magnetars could help us better understand extreme events in the universe, such as the formation of black holes or the explosion of supernovas. Every time we detect a gravitational wave, it's as if we're receiving a message from the cosmos, a message that speaks of events that occurred millions of years ago. As we improve our technology and understanding, more and more messages of this kind could be deciphered. It's also worth mentioning that magnetars are not the only ones responsible for the production of gravitational waves. However, their magnetic uniqueness and dynamic nature make them ideal candidates to be studied in this context. every discovery related to them brings us one step closer to unraveling the mysteries of the universe. Now, imagine a future where the detection of gravitational waves becomes commonplace. In that scenario, magnetars could become a kind of cosmic beacons, guiding us through the vast expanses of space. These beacons would not only help us better understand the universe, but they could also have profound implications on the nature of gravity and space-time, concepts that have fascinated scientists for centuries. For those who still wonder if all this is relevant to us, the answer is a resounding yes. The study of magnetars and gravitational waves not only helps us better understand the cosmos, but it also offers us a perspective on our own existence. By exploring what lies beyond our planet, we connect with the universe in a deeper and more meaningful way. So next time you look at the night sky, remember that those bright spots are not just stars. They are potentially sources of valuable information about the mysteries of the universe. Magnetars, with their extreme energy and magnetism, are a reminder that there is still much to discover and learn. Every time we listen to a gravitational wave, we are hearing an echo of the universe's history, a story that continues to unfold before our eyes. Magnetars are more than just stars. They are genuine cosmic factories that can influence the formation of new stars and the evolution of galaxies. But how is it possible for these magnetic giants to have such a profound impact on their environment? The answer lies in their extraordinary energy and powerful magnetic field. When a magnetar forms, it is usually the result of the explosion of a massive star. This event not only releases enormous amounts of energy, but can also alter the surrounding environment. Imagine a fireworks explosion, but on a cosmic scale. The energy released can be so intense that it can compress nearby gas and dust, creating ideal conditions for new stars to begin to form. It's as if these magnetars act as catalysts in the vast workshop of the universe. When a magnetar forms, it is usually the result of the explosion of a massive star. This event not only releases enormous amounts of energy, but can also alter the surrounding environment. Imagine a fireworks explosion, but on a cosmic scale. The energy released can be so intense that it can compress nearby gas and dust, creating ideal conditions for new stars to begin to form. It's as if these magnetars act as catalysts in the vast workshop of the universe. The influence of a magnetar doesn't stop there. Its magnetic field, which is billions of times stronger than Earth's, can affect the behavior of matter in its proximity. This extreme magnetic field can attract and organize gas clouds, helping to shape new stars. Thus, the life of a magnetar not only ends with its own existence but can give rise to a new generation of stars. Imagine a giant magnet that, when placed on a table full of iron filings, aligns them in orderly patterns. Similarly, the magnetic field of a magnetar can organize the gas and dust around it, creating dense regions where new stars can form. This process can be fundamental to the evolution of galaxies, as without the intervention of these cosmic magnets, conditions in space could be very different. The relationship between magnetars and star formation is also reflected in time. As a magnetar fades, it can leave behind a trail of matter and energy that, over time, will become new stars. This legacy of a magnetar is comparable to how a dead plant can enrich the soil for new plants to grow. Thus, the life cycle of a magnetar is a cycle of creation and destruction, where its end can be the beginning of something new. Furthermore, magnetars not only influence gas and dust, but they can also affect stars that are already forming. The intense radiation and gamma-ray bursts they can emit alter the environment, creating ideal or adverse conditions for the development of other stars. It's as if a magnetar had the power to decide which stars should shine and which should not. As scientists continue to study these phenomena, they have realized that the presence of magnetars can be an indicator of a galaxy's health. The quantity and distribution of these cosmic magnets can offer clues about how a galaxy has evolved over time. Did you know that some galaxies may have more magnetars than others? This can suggest different formation and evolution stories, helping us better understand the universe as a whole. Some astronomers believe that magnetars could be key to understanding the formation of larger structures, like galaxy clusters. These massive objects have the potential to influence the gravity and dynamics of the galaxies that surround them. Thus, magnetars become fundamental pieces in the puzzle of cosmology. Although magnetars seem to be distant and mysterious objects, their study offers us a unique window to understand our own place in the cosmos. Through them, we can learn about the processes that shape the galaxy we inhabit. The evolution of our universe is intertwined with the life and death of these cosmic magnets, and each discovery brings us a little closer to unraveling the secrets of space. The story of magnetars is not just a story of stars, it's a story of influence and creation. In the vast universe, each magnetar has its own role in the grand cosmic theatre, reminding us that even the most extreme phenomena can be part of a broader life cycle. As scientists advance in their research, we may discover even more about how magnetars affect star formation and the evolution of galaxies. Perhaps in the not-too-distant future, we can observe these cosmic magnets in action, becoming witnesses to their transformative power. So the next time you look at the starry sky, remember that among those twinkling lights, there could be the echoes of magnetars that, at one time, played a crucial role in the history of the universe. The fascination with these extreme cosmic objects not only lies in their nature but also in the way they connect us with the past and future of the cosmos. In conclusion, magnetars are more than just stars. They are engines of creation and evolution in the universe. Their influence extends beyond their own existence, affecting everything around them and leaving a legacy that endures through time. As we continue to explore the cosmos, magnetars will remain a topic of interest and study, revealing more and more about the complexity and beauty of the universe. Magnetars have captured the imagination of many, not only for their extraordinary nature, but also for their representation in popular culture. But what role do they really play in our perception of the cosmos? Why have they been chosen as protagonists in various science fiction narratives and films? The fascination for these extreme cosmic objects goes beyond their impressive magnetic force. It extends to the way they make us reflect on the universe and our place in it. In science fiction movies and series, magnetars are often depicted as inexhaustible energy sources, or even as catalysts for catastrophic events. For example, in some plots, the explosion of a magnetar can be the event that triggers a series of catastrophes on Earth. This narrative is not just creative license, It has roots in reality, as gamma-ray bursts from a magnetar could, in theory, have devastating effects on our planet. However, most of these representations tend to exaggerate the immediacy of the danger, transforming magnetars into cosmic villains rather than simple astronomical phenomena. Some literary works have explored the idea that magnetars could be portals to other dimensions or realities. In these stories, the intense magnetic field of a magnetar not only affects the surrounding space, but also distorts the fabric of reality itself. This idea, although purely fictional, invites us to think about the possibilities that modern physics offers us and how scientists might, one day, discover new dimensions of the universe through the study of these objects. Video games have also taken inspiration from magnetars, presenting them as energy sources that players must harness or avoid. In many of these games, the magnetar becomes a strategic objective, where players must learn to navigate its effects, often represented in a dramatic and visually striking way. This playful interaction not only entertains, but also arouses curiosity about astrophysics in those who might never have been interested in the subject. However, not everything is fiction. The reality of magnetars has influenced documentaries and educational programs where they are presented as wonders of the universe. These productions not only inform, but also seek to inspire new generations of scientists. By showcasing the beauty and mystery of magnetars, they foster a sense of wonder that can motivate young people to explore careers in science and technology. Magnetars have also found their place in music. Some compositions have been inspired by these cosmic magnets, using sounds that evoke the immensity of space and the power of magnetic fields. This fusion of art and science demonstrates that human curiosity about the cosmos can manifest itself in multiple forms, from literature to music. The representation of magnetars in popular culture also raises philosophical questions. What does it mean to be an extreme cosmic magnet in such a vast and enigmatic universe? These questions lead us to reflect on the nature of existence and our understanding of time and space. In popular culture, magnetars often symbolize forces that are beyond our control, which can resonate in our daily life. It is interesting to note that, despite their extremely technical and complex nature, magnetars have become an accessible symbol of modern science. This phenomenon shows how science can be demystified and presented in a way that resonates with the general public. In this sense, magnetars act as a bridge between popular curiosity and scientific knowledge. The way magnetars are presented has also changed over time. In early representations, they were simply seen as more neutron stars. However, as science has advanced and our understanding of these phenomena has grown, their representation has evolved, reflecting a deeper understanding of their unique features. This is a testament to how science and culture are intrinsically connected. Finally, the story of magnetars in popular culture is a reminder that scientific knowledge is not reserved only for experts. We can all participate in the conversation about the universe, and magnetars are a fascinating starting point. They invite us to question, explore, and above all, marvel at the immensity and complexity of the cosmos. As we continue to explore these extreme cosmic magnets, it is essential to remember that each new piece of information can inspire new stories. Magnetars are more than objects of study. They are a symbol of our relentless quest for knowledge and understanding. And so, through science and culture, magnetars will continue to be a source of inspiration, awe, and perhaps a spark that ignites the curiosity of future generations. In the vast universe, magnetars present themselves as fascinating enigmas, and scientists have dedicated significant efforts to unravel their mysteries. What does future research hold for these extreme cosmic magnets? The answer to this question not only involves exploring their nature, but also delving into the search for tools and technologies that allow us to observe them more clearly. A key aspect is the evolution of telescopes. As technology advances, so do our capabilities to study complex phenomena. Imagine a telescope that can not only capture visible light, but also radio waves and gamma rays, which are essential for understanding the activity of magnetars. These futuristic instruments, equipped with sophisticated sensors and algorithms, will give us a broader view of the universe. Will we then be able to see a magnetar in action, emitting its powerful energy pulses? International collaboration has become fundamental in the search for answers. Institutions from around the world are joining forces to build observatories that work together. This approach allows us to combine data from different regions of the electromagnetic spectrum, creating a more complete picture of magnetars and their behavior. What astonishing discoveries will emerge from this global cooperation? Space missions will also play a crucial role in the study of magnetars. Imagine a probe delving into deep space, equipped with tools specifically designed to analyze the radiation emitted by these objects. This type of exploration will not only expand our knowledge about magnetars, but it could also reveal information about star and galaxy formation. Are we on the verge of a revolution in astrophysics? In addition, advances in artificial intelligence are transforming the way we analyze data obtained from magnetars. Intelligent algorithms can process vast amounts of information in seconds, identifying patterns that could go unnoticed by researchers. What hidden secrets will these systems unveil in the near future? Studies on the effects of magnetars' magnetic fields are also on the agenda. Understanding how they influence surrounding matter and the formation of new celestial bodies could change our understanding of astrophysics. Are we facing the possibility that magnetars are responsible for creating new stars in the universe? Each discovery opens the door to new questions. On the other hand, the importance of magnetars in gravitational wave research cannot be underestimated. As new detectors are developed, the possibility of observing events related to magnetars becomes increasingly real. Will we be able to capture the gravitational waves generated by the collision of two magnetars, thus revealing a new chapter in the history of the universe? As we delve deeper into magnetar research, questions also arise about their relationship with quantum physics and relativity. Could it be that these extreme objects help us understand the limits of our current theories? The intersection between relativity and quantum physics is fertile ground for new ideas, and magnetars could be the key to unlocking the mysteries that still elude us. Future research will also focus on the diversity of magnetars. Not all are the same, some are more active than others, and their characteristics can vary considerably. What will the differences between these objects tell us about their formation and evolution? By studying a variety of magnetars, we can build a more complete map of these phenomena and their origins. The fascination with magnetars has also led to the exploration of their possible influence on life on Earth. While they are thousands of light years away, their gamma-ray bursts could have effects on our planet. Could a magnetar in our galaxy be a threat to life on Earth? These are questions that scientists must consider while investigating the potential effects of these objects on our environment. Popular culture has also begun to take note of magnetars, which in turn helps to increase public interest in astrophysics. More and more movies, books, and science fiction series are referencing these cosmic phenomena. Could this inspire a new generation of scientists and astronomers? The connection between science and popular culture is a powerful tool for fostering curiosity and exploration. Thus, the future of magnetar research is full of promises and challenges. Through global collaboration, technological advances, and innovations in data analysis, we are closer than ever to unveiling the secrets of these cosmic magnets. What discoveries await us in the coming years? Undoubtedly, the journey towards understanding magnetars will be an exciting chapter in the history of astrophysics. Each answer we obtain will open the door to new questions and possibilities, and so the cycle of knowledge continues, illuminating the path to the future. Exploring magnetars is not without challenges. In fact, these enigmatic cosmic objects sit at the edges of our current knowledge. But why are they so difficult to study? One reason is their extreme nature. Imagine a place where gravity is so intense it can bend space and time. Magnetars are like this, but they also possess a magnetic field that can be billions of times stronger than that of a common magnet. This means that any instrument attempting to measure their activity has to be extremely sophisticated. Distance also plays a crucial role. Most known magnetars are thousands of light years away from us. To put it into perspective, have you ever tried to listen to someone whispering from the other side of a large auditorium? That's roughly the difficulty scientists face when trying to capture signals from these objects. Despite the power of their gamma-ray bursts, the light that reaches us can be very faint and at times gets lost in the vast ocean of cosmic radiation that surrounds us. Another challenge is the short duration of their bursts. The gamma-ray eruptions they emit can be fleeting, and like a flash of light, appear and disappear in the blink of an eye. This raises the question, how can phenomena that are so brief be studied? Astronomers must always be on alert, ready to capture any signal that might emerge in the sky. It's like trying to catch lightning with the net. It requires patience and constant vigilance. Technology also presents its own limitations. Although we have made great strides in building telescopes and X-ray detectors, there is still much to do. For example, current telescopes may not be sensitive enough to detect subtle changes in a magnetar's behavior. This leads us to ask, what new technologies will we need to unravel the secrets of these magnetic giants? The answer could lie in creating more powerful telescopes and combining data from multiple observatories around the world. Adding to this is the complexity of the magnetars themselves. Each one can behave differently, making their study even more complicated. Are they behaving as expected, or are there unknown factors influencing their activity? These questions have no easy answers and open the door to a world of ongoing research. Imagine being a detective on an unsolved case, where every clue leads to more questions than answers. Moreover, the environment in which magnetars are found is not the friendliest. The intense radiation they emit can interfere with our measurements. Scientists must design experiments that are not only capable of capturing the light from these objects, but also resistant to the radiation they themselves generate. This is similar to trying to take a picture in a thunderstorm. You need special equipment and a good dose of luck. International collaboration also becomes an essential element. Since magnetars can be observed from different places on Earth, many researchers are working together to combine their findings. Can you imagine how many countries and scientists must coordinate to study a single magnetar? The answer is that it takes a global team, where each small discovery can be the key to better understanding these phenomena. In addition, there is the need for funding. Astrophysical research is expensive and often resources are limited. This raises the question of how research projects are prioritized. Which magnetar deserves more attention? What discovery could change our understanding of the universe? The decisions made at the funders' tables are crucial for the future of research in this field. We cannot forget the role that theory plays in magnetar research. Many of the ideas we have about their functioning come from physical theories that are still being developed. This means that scientists must be willing to adapt or even change their theories as new data emerges. Sometimes what seems like a rule can become an exception, challenging our previous notions about how these stars work. Lastly, there is the impact that magnetar research has on other scientific disciplines. Findings in astrophysics can influence fields such as quantum physics or relativity. This intertwining of disciplines reminds us that knowledge is not compartmentalized. What implications could magnetars have for our understanding of physics in general? Each answer can open a new path of research that we have not yet imagined. Despite all these obstacles, human curiosity continues to drive research. Each small advance in our understanding of magnetars is a victory. Perhaps the next big discovery is just around the corner, waiting to be revealed by a scientist in the right place at the right time. The quest for answers about these fascinating cosmic objects continues, and with each new question, we get a little closer to unraveling the mysteries of the universe. What would happen if I told you that magnetars, those mysterious and powerful cosmic objects, have a lot to teach us about quantum physics? In a universe where the laws of physics are constantly challenged, magnetars stand as an enigma that could help us better understand the behavior of matter at subatomic scales. But why are these stars so special? What is their relationship with the fascinating world of quantum physics? To understand this, we must first remember that quantum physics deals with the smallest particles that make up our universe, such as electrons and protons. Imagine a world where the rules of the game are completely different from what we're used to seeing in our daily life. In this microcosm, particles can act as if they were waves. They can be in multiple places at once. And sometimes they can even communicate instantly across great distances. This strange reality is what quantum physicists try to unravel. Magnetars, on the other hand, are a special type of neutron star with extremely intense magnetic fields. much more than those of any other known object in the universe. Their magnetic field can be 1 billion times stronger than that of a fridge magnet. Can you imagine the force of a magnet that could attract objects thousands of kilometers away? That's the magnitude of what we're talking about. But how does this relate to quantum physics? The extreme magnetic fields of magnetars can affect the behavior of the subatomic particles around them. In this sense, they become natural laboratories where quantum phenomena that would otherwise be impossible to study can be observed. For example, the intense gravity and magnetic fields of a magnetar can cause particles to behave in a way that defies our intuitions about how they should interact. Imagine a dance floor where the normal rules are broken, and dancers start moving in unexpected and unpredictable ways. Studies on magnetars have also led scientists to re-evaluate some of the fundamental theories in quantum physics. What if magnetars revealed new aspects of matter and energy to us? The possibility that these stars could provide us with clues about the nature of quantum gravity is exciting. Quantum gravity is a research area that seeks to unify Einstein's general relativity, which describes gravity, with quantum mechanics, which explains the behavior of particles. The relationship between magnetars and these concepts could be key to unveiling the secrets of the universe. In addition, magnetars are known for their gamma-ray bursts, which are extremely energetic events. Gamma rays are the most energetic form of radiation in the electromagnetic spectrum, and studying how they are generated in magnetars can shed light on the behavior of matter under extreme conditions. By observing these phenomena, scientists can gain information about the internal structure of a magnetar and how its magnetic forces affect subatomic particles. When magnetars release energy in the form of X-ray pulses, they also offer a unique opportunity to study quantum physics. These pulses are like flashes of light that allow us to glimpse the behavior of matter under extreme conditions. By analyzing the characteristics of these pulses, scientists can infer properties about the matter and energy that make up the magnetar. Isn't it fascinating to think that by observing a magnetar millions of light years away, we can learn about the very essence of matter? But the story doesn't end there. The way magnetars interact with their environment can also influence quantum physics. For example, the intense radiation they emit can alter the behavior of particles in the surrounding space, creating an environment where quantum rules manifest differently. This phenomenon could offer new paths to investigate how the fundamental forces of nature interact with each other. Think of magnetars as a huge cosmic puzzle. Each piece of this puzzle represents a different aspect of physics, and by studying these stars we are trying to fit all the pieces together to get a more complete picture of the universe. What secrets will they reveal to us in the future? Research on magnetars is in full swing, and each new discovery could change our understanding of quantum physics. The relationship between magnetars and quantum physics also raises intriguing questions about the nature of the universe. Could these cosmic objects be the key to understanding phenomena that we have not yet discovered? The exploration of magnetars and their impact on quantum physics could open new doors in our search for answers about the cosmos. In summary, magnetars are more than just stars. They are carriers of secrets that can unveil the complexities of the universe. As we delve deeper into their study, the connections with quantum physics become increasingly evident, and each discovery propels us towards a greater understanding of the very nature of matter and energy. Who knows what other cosmic mysteries await us as we continue our exploration of these fascinating phenomena? Science advances, and with it, our ability to understand the universe in its entirety. Magnetars are a fascinating mystery in the vast universe, and their study has led scientists to formulate various theories about their nature. But what makes these theories so intriguing? To start with, one of the most important questions is, where does that incredible magnetic force they possess come from? Some suggest it could be the result of an extremely violent stellar collapse, where the star's rotation and its magnetic field combine in an energy explosion that produces a magnetar. This combination of factors could be the key to understanding why these objects are so unique. Another theory suggests that magnetars could have been neutron stars that, after a supernova event, experienced an increase in their magnetic field due to rapid rotation. Imagine a spinning top spinning faster and faster. As it spins, its energy increases, and something similar could be happening with these cosmic objects. But what implications would this have for our understanding of time and space? In addition, the question arises, could magnetars be a bridge towards the unification of forces in physics? The idea that such an extreme and unique object as a magnetar could contain the clues to combine gravity and electromagnetism is fascinating. Some physicists believe that the study of these celestial bodies could lead to new discoveries in quantum physics, which would lead us to a new understanding of the universe. One of the most intriguing theories is the idea that magnetars could be the result of a formation process that we do not fully understand yet. Could there be other dimensions or phenomena that influence the creation of these objects? The notion that there is more at stake than what we see at first glance invites us to explore beyond what we know. The theory that a magnetar could be a kind of mother star that gives rise to other celestial bodies is also fascinating. If a magnetar can influence its environment through its magnetic field, could it be playing a vital role in the formation of new stars? This leads us to question how magnetars could affect the evolution of galaxies, and if they are, in some way, architects in the cosmos. We cannot ignore the influence of magnetars on the matter around them. Some scientists believe that their powerful magnetic field could even alter the structure of atoms in their proximity. Are these cosmic forces creating new forms of matter or altering the current ones? The implications of this are huge, as they make us reconsider what we understand about matter and energy. And in an even more surprising twist, there are theories suggesting that magnetars could be related to the existence of gravitational waves. How can such a distant object be connected in this way with phenomena that occur here, in our own environment? This opens a new field of study in astrophysics, where these events are sought to be correlated to improve our understanding of the universe. Variations in the behavior of magnetars have also led to theories suggesting that they may be interacting with other forces of the universe in ways we do not yet understand. Could it be that they are influencing the expansion of the universe, or even gravity itself? These questions lead us to explore areas of physics that are at the frontier of our current understanding. As we advance in the research of magnetars, we also find theories about their possible connection with life on other planets. Can these extreme objects have an impact on the habitability of nearby planetary systems? The theories exploring this idea are even more exciting, as they make us wonder about our own existence and the place we occupy in the vast cosmos. In the end, this study of Magnetars is not just an academic exercise. Each theory that emerges from the research of these extreme cosmic objects leads us to question and rethink our beliefs about physics and the nature of the universe. What else could we discover by continuing to explore these phenomena? The search for answers about Magnetars is a journey that is just beginning. With each new discovery and each theory that develops, new doors open towards knowledge. Human curiosity, that spark that drives us to explore the unknown, is still alive in this field, leading us to a deeper understanding of our place in the universe. As we continue to investigate, it is essential to remember that each theory that is proposed is a piece of a much larger puzzle. And although we do not have all the answers now, the search for the truth about Magnetars and their nature will continue to challenge and inspire us to discover what is still hidden in the vast confines of the cosmos. In the vast ocean of the cosmos, Magnetars present themselves as enigmatic beacons of knowledge that illuminate the secrets of the universe. But what lessons can these powerful celestial bodies teach us about our place in the cosmos? The answer to this question is as fascinating as the Magnetars themselves. First, let's consider their extreme nature. Being the most potent magnets in the universe, Magnetars generate magnetic fields trillions of times more intense than those of Earth. This force is not just an isolated phenomenon, it has profound implications in fundamental physics. It forces us to question how matter interacts under extreme conditions and how these interactions can influence the behavior of matter throughout the universe. What better way to understand gravity and electromagnetism than through these cosmic giants? Moreover, the activity of Magnetars is related to phenomena that, at first sight, seem to be far beyond our reach. The gamma-ray bursts they emit are like cosmic fireworks, and their study can reveal clues about the creation of elements and the dynamics of galaxies. Who would say that such a distant phenomenon could have implications in understanding the formation of the matter that makes up our own planet? Magnetars also offer us a unique window into the past. The way they form and evolve intertwines with the history of the universe itself. By observing a magnetar in a way, we are looking back in time, understanding how massive stars explode and give rise to these magnetic colossi. This temporal connection reminds us that the universe is a dynamic place, constantly changing, and that every star we see in the sky has a story to tell. But what does this mean for us as a species? Research on magnetars can help solve some of the deepest mysteries of physics. For example, how do subatomic particles behave under conditions of extreme gravity? By studying magnetars, scientists are challenging and expanding our current theories, bringing us one step closer to understanding the fundamental laws that govern our universe. Magnetars also teach us about the life and death of stars, their life cycle, which goes from the explosion of a supernova to their transformation into a magnetar. It's a reminder of how ephemeral existence is. By reflecting on these transitions, we can find parallels in our own lives. Transformation is inevitable, and often necessary for growth and evolution. Another intriguing aspect of magnetars is their influence on the formation of new stars. Their powerful magnetic field can affect the gas and dust in their surroundings, creating conditions that facilitate the formation of new stars. This raises a fascinating question. Could magnetars be catalysts in the stellar life cycle, influencing the creation of new generations of stars and with them new planetary systems? And we cannot forget the cultural impact they have. Magnetars, although distant, have captured our imagination and appear in science fiction and literature. Their representation in these media not only shows their aesthetic appeal, but also invites us to reflect on our place in the universe. It challenges us to think about the possibilities of life on other worlds and the cosmic forces that could be at play. Moreover, as technology advances, the study of magnetars could open new doors in understanding energy and matter. Imagine if we could learn to use the energy of these giants for our own benefit. Although it sounds like something out of a movie, advances in physics could one day allow us to harness cosmic forces that now seem unreachable. Human curiosity is intrinsically linked to our quest for knowledge. The exploration of magnetars, although challenging, leads us to question what we know and what we still have to discover. Each new finding about these objects pushes us to rethink our understanding of the universe and ultimately of ourselves. In this journey of discovery, international collaboration among scientists also plays a crucial role. The science of magnetars knows no borders, and research teams from around the world work together to unravel the mysteries that these celestial bodies present. This union of minds is a powerful reminder that, although we are separated by vast distances, we share a curiosity and a desire to understand our place in the cosmos. Finally, the study of magnetars has implications that go beyond astrophysics. They teach us about resilience and adaptability. Just as a magnetar can arise from the explosion of a massive star, we too can find strength in adversity. Each lesson we learn from these cosmic colossi can inspire us to face our own challenges. In summary, magnetars are not just astronomical phenomena, they are cosmic teachers that teach us about life, the universe, and our role in it. By continuing to explore and study these fascinating objects, we not only expand our scientific horizons, but also move closer to a greater understanding of our own existence in this vast and mysterious cosmos. As we conclude our fascinating journey through the world of magnetars, it's important to pause for a moment and reflect on what we have learned. What do these cosmic objects teach us about the universe we live in? They are like bright beacons in the darkness of the cosmos, illuminating not only their surroundings but also our understanding of physics and astrophysics. Magnetars, with their extreme magnetic fields, challenge our understanding of matter. Have you ever thought about how a magnetic field can be so powerful that it can alter the behavior of the surrounding matter? Imagine a magnet that not only attracts small objects, but can affect even the structure of space itself. This is what magnetars do, and their study helps us understand the fundamental forces that govern the universe. The life of a magnetar is an awe-inspiring cycle, from its formation to its eventual disappearance. But what does this mean for us? It reminds us that the cosmos is a place of constant change, where the death of a star can give way to the creation of new forms of life and matter. In this sense, magnetars are a reminder of the interconnectedness of everything in the universe, of how every cosmic event has repercussions in the very fabric of space and time. When talking about magnetars, we are also touching on Einstein's theory of relativity. How is it possible that such a massive and dense object can influence the curvature of space-time? The answer takes us to the limits of our knowledge and invites us to think beyond what we know. Relativity is not just a theory. It is an open door to new possibilities and discoveries. Furthermore, the connection between magnetars and gravitational waves shows us that these phenomena are not only interesting in themselves, but are also powerful tools for exploring the universe. What secrets will gravitational waves reveal to us in the future? This is a question that scientists are eager to answer, and each new observation about magnetars could bring us one step closer to understanding the mysteries of the cosmos. One of the most intriguing aspects of magnetars is their impact on star formation. How can such an extreme object influence the creation of new stars and galaxies? In a sense, magnetars are like the architect of the cosmos, shaping the environment in which new stars and planetary systems form. This symbiotic relationship is fundamental to understanding how the universe develops over time. Popular culture has also begun to reflect the fascination with magnetars. How many movies or books have you seen that draw inspiration from these cosmic phenomena? Science fiction often feeds on real science, and magnetars are a perfect example of how scientific curiosity can inspire imagination. This leads us to consider how magnetars influence our perception of science and the cosmos, bringing people closer to topics that might otherwise seem distant or abstract. However, not everything is easy in the study of magnetars. The challenges are significant. What limitations do researchers face in their quest for answers? From the distance that separates us from these objects to the very nature of the phenomena they produce. Each discovery comes with its own set of complications. But it's precisely this challenge that makes science so exciting and rewarding. Quantum physics also plays a role in understanding magnetars. How do these giants interact with the laws of quantum mechanics? As we explore these connections, our knowledge of the universe expands, and each new finding opens doors to even more complex theories and concepts. Finally, let's reflect on the implications of magnetars for humanity. What can they teach us about our place in the universe? Understanding magnetars is not just an academic exercise. It's an exploration of our very existence and how we relate to the cosmos. It shows us that, although we are small compared to these gigantic stars, our curiosity and our ability to learn and adapt are what define us as a species. As we conclude our exploration, it becomes clear that magnetars are much more than simple objects of study in space. They are part of a complex web of forces and phenomena that shape our universe. The curiosity they awaken in us is just the beginning of a journey that promises to unveil many more secrets in the years to come. What new wonders await us in the vast cosmos, only time will tell.